Tiger 131 is not just a museum highlight, it's a forensic time capsule. Captured by the British 48th Royal Tank Regiment in Tunisia during the North African Campaign on 24 April 1943, this Tiger 1 was shipped to Britain, studied in detail, and today remains the world's only running Tiger 1 at the Tank Museum in Bovington. Design came first. The Tiger 1 was designed as a breakthrough heavy tank. It was heavy, but the concept was deliberately simple. The hull and turret are made from large, mostly flat plates of rolled, homogeneous steel with interlocking joints instead of complex sloping. This construction provided significant thickness, 100 millimeters on the hull front, up to 120 millimeters on the mantlet, and 80 millimeters on the turret sides. But the flat shape removed the advantages of slope. Crews had to angle the hull, the so-called Sichtstellung, to increase effective thickness in combat. The turret was a large, cast and welded unit with a powerful traverse system. Its mass and shape made it both durable and slow to speed up. Mobility and suspension were also important. To support that heavy protection and the long 88mm gun, the Tiger used torsion bar suspension and very wide tracks, inspired by the T-34 design. This setup resulted in lower ground pressure than one might expect for a tank weighing 57 tons, which helped in cross-country movement. However, the trade-offs were clear. Combat weight was in the mid-50-ton range. Complex driveline and transmission parts were strained by the weight, and fuel consumption along with maintenance needs were demanding in the field. In short, strategic mobility and logistics became as critical as raw battlefield performance. The development of the power plant is crucial for understanding the Tiger's practical limits. Early Tigers used the Maybach HL210 aluminum block 21Ls, which was seen as underpowered for the increasingly heavy production vehicle. Maybach enlarged the design into the HL230 cast iron block 23Ls, increasing displacement and peak power. The HL230 later became standard in the Tiger and Panther series. This change improved torque and durability, but the heavier cast iron build added weight and required limiting factory RPM and operational revolutions to protect engine life. A reminder that more power meant more thermal and mechanical strain. During the restoration of Tiger 131, the museum installed an HL230 from a Tiger II to get it running again, an example of how closely engine design and serviceability were connected. What about armor versus Allied guns? Penetration tables from that time and Allied tests show the 88mm KWK-36 could reliably defeat most others at combat ranges. The Tiger could engage enemy armor at distances where the opponent's gun could not expect to succeed against the Tiger's frontal plates. On the other hand, standard Allied 75mm and early 76mm tank guns could not reliably penetrate the Tiger's front at typical combat distances. Only higher performance weapons, especially the British 17-pounder in the Firefly conversion, and later high-velocity US 90mm and 76mm HV rounds, achieved consistent frontal kills. This mismatch forced Allied formations to change their tactics. They concentrated fire, aimed for side shots, used ambushes, or deployed specialist anti-tank assets. Captured Tigers, particularly Tiger 131, had a significant impact. After being shipped to Britain and tested at the School of Tank Technology, these vehicles produced detailed technical reports that informed Allied countermeasures. This included ammunition development, tactics for angling and approach, and the creation of Firefly conversions and specialized tank destroyers. Practically studying running components, transmissions, turret rings, radios, and engine design gave engineers and tacticians a clear view of both the Tiger's strengths and weaknesses. That knowledge turned a nearly mythical opponent into a set of manageable engineering and tactical challenges. Today, Tiger 131 still shows the scars of capture and signs of restoration. It serves as a living exhibit that highlights where a 6-pounder solid shot disabled turret movement. This tells both the story of a single combat and the larger narrative of how technology, logistics, and tactics work together on the battlefield. For historians and engineers alike, it remains a unique operational laboratory,